Good morning, everybody. Okay. We have a lot to do today, so we're going to get started. Go. Screen. Okay. Okay, so we are going to spend the first half hour or so talking about data types and data structures. And then we're going to do some class coding, meaning we're going to code as a group. We'll ask for a volunteer to lead us in that effort. So you can start thinking about if you want to do that. We'll need someone who has a PyCharm up and running on their computer. And so at around 10:30 or so, if I'm still talking, you interrupt me and tell me you promise we're going to do coding. All right. So obviously, data structures are very important to algorithms. First of all, you need a data structure on which to do most algorithms. But number two, the choice of data structure is often critical to the performance of the algorithm. So it's appropriate to do some review of this before we really get going with the course. And we have, first of all, some primitive data types, right? So every programming language has some primitive data types. These are usually relatively small in terms of the space that they take up, and then they form the building blocks for some bigger data types. All right, so we have a Boolean, right? What's an example of a Boolean? What kind of values can it take on?
True or false?
True or false. Okay. In some programming languages, that Boolean may just be really an integer in disguise. That's true, for example, in some database systems, right? The Boolean is really just a small integer, either 0 or 1. Then we have a character.
It's just A, B.
Things like A, B, question mark, right? Punctuation marks, foreign language characters in foreign languages are also characters. All right. Then we have numbers. Okay, I have 3 different kinds of numbers here, possibly 4, depending on how you count things. So we have integer. I think integer is fairly self-explanatory. Of course, we could have different kinds of integers, longer ones, shorter ones. What's the difference between a fixed point and a floating point number? So bullets 3 and 4. So both are used for decimal numbers, but the difference is in a fixed point number, we have a fixed number of decimal places. So we might say, okay, all of our numbers are going to have 3 decimal places. That's an example of a fixed point number, whereas a floating point number allows it to vary. So if I need 20 decimal places, it'll have 20 decimal places. If I only need 2 of them, I only use 2 of them. So we have that flexibility that's sort of built in. Right, we also have a reference or a pointer, which often is just an integer, right? It allows you to point to a position in memory. And then we have an enum, or enumerated type. Anyone know what that is? So that is a variable whose values are limited. In other words, it can't be any old integer. It can't be any old character. Right, it's limited to a defined set of values. So, for example, you might have, in a college, you might have, everyone is either of type freshman, sophomore, junior, or senior, or maybe graduate student, right? So you're limiting your values to a well-defined set, and then many programming languages allow us to have a date, a time, or some kind of date time. Right, so again, these are some of the primitive data types. By the way, where is string? You don't see string here. That's a pretty important data type. Why isn't it here?
Not a primitive data type, it can add characters.
Well, yeah, it really isn't so primitive, right? Because it has a whole bunch of things in Java in particular, right? A string is it's an object and has many functions associated with it. So it's not so primitive. All right, so that brings us to our non-primitive data types. Okay, and we have an array, right? An array is a sequence of generally the same data type, right? So you can have an array of characters, an array of integers, an array of dates, right? We could have some kind of a record, also known as a structure, also called an object, where you have different attributes or different data types within that record, and they can be all different things, right? So you could have a person record and it's got a name, which is a string. It has a phone number, which is a number. It has a birth date, which is a date, right? So it could have many different data types built into that. And then you could have what they call a union. Okay, a union is like a hybrid of things. Okay, so for example, a list might fall into that category, right? Because in a list, you don't necessarily have a list all of the same type of object, right? The first element may be a string, and the second element may be a number, and the third element may be a date, right? So that's another example of a non-primitive data type. All right, then we have abstract data types. So in your data structures class, you probably talked about that quite a bit. And the key thing about an abstract data type is the focus is on the behavior and the features, the properties, and not on how it's actually implemented. So first of all, it has to have a type itself. It has an interface, which means what operations are supported, right? So those are like functions without the actual implementation of the function. It's saying, and we'll give examples of this, but we'll talk about stacks momentarily, right? So a stack needs to support a pop operation, a push operation, an isEmpty operation, right? Maybe an empty operation, which empties everything out, right? So those are the operations that are supported, but we don't necessarily know how they're implemented. And then another important feature of the abstract data type is encapsulation, which says that we have all these things that are sort of inside the abstract data type, and we don't have access to them on the outside, right? Everything needs to happen through the operations. So these are some of the important abstract data types. We have a container. All right, what is a container? Sometimes it's called a collection. Anyone want to say what that is? So I'll give you a little bit of a hint. I don't know if this makes it easier or harder, but a lot of the things actually on this list are kinds of collections, right? A list is a collection. Stack is a kind of collection.
Like arrays.
Yeah, well, array is more of a specific implementation, but basically it's something that can contain many different things. Okay, and that's where we get into some of the nuances in some of the more specific things listed below. So for example, a list is a kind of container or a kind of collection, but what features does a list have that isn't true, let's say, all collections? So in a list, there's generally going to be a beginning. You may have access to an end as well. You have a next operation, right, to go from one thing to the other, right? So that's specifically a list. Here's a question that we don't necessarily know the answer to, but it's something to think about when dealing with abstract data types, is can you have the same element more than once? So is that true of a collection in general?
Can you repeat that one more time, please?
Yeah, so one of the questions we need to ask about an abstract data type is whether you can have the same element more than once. Or another way to say it is, are the elements unique? Let's take a list, for example. In a list, are all the elements unique?
Yeah.
Not necessarily, right? You could have a list with something multiple times, right? So that's something you need to, verify when you're creating a list. Are we allowing to have duplicates? All right, what's a tuple and how is it different than a list? So a tuple is also a sequence of elements. The order is important, but a tuple is different from a list in that it is immutable. Anyone know that word, immutable?
Like can't change.
Can't change, right? So the tuple is what it is. A list, you can delete things, you can insert things, you can put them at the end, at the beginning, you can change and replace one element with another. A tuple is immutable. You can't change. All right. If you want to change it, you just replace it with a different tuple, but you can't, change the actual tuple itself. Right. Then we have a map. For those who like Python, in Python, we generally call it a dictionary. And in some languages, let's say JavaScript, we usually refer to it as an associative array. And what is that? How would you describe a map or a dictionary? Some of you may know it as a hash map. It uses some kind of function to do this mapping, right? So in a map, we have keys and values, right? It's sort of like, why do they call it a dictionary? Because in a dictionary, you look up a word in the dictionary and there's a value for it, right? There is a definition for it. So that's what a map is. It's keys and values. Now, can you have duplicates there? Can you have the same key more than once in a map, in a dictionary?
No.
No, no. What about the same value?
Yes.
Yes, right. So you can have two keys that map to the same value. That's actually very common, right? Sometimes your dictionary will be there to indicate whether something is yes or no, whether it's there or not. So you'll use like a 1, 0 or a true or false, right? So many keys will have a true, many keys will have a false, right? Or many will have a 1, many will have a 0, right? There is something called a multi-map. A multi-map is a variation in the map theme that allows you to have multiple values for the same key. Okay, so typically a map is, key and value. Multi-map is key and possibly multiple values, right? Then we have a set, right? So a set is sort of like a list, sort of like a tuple. So what's different about a set?
It has unique elements.
Okay, so the elements need to be unique. Good. Okay, it should support, is it ordered? Does the order in a set matter?
No, it doesn't.
No, it doesn't.
No.
Correct. Okay, and it should also support, operations like union and intersection and maybe subtraction, right? Set difference. All right. There is something called a multi-set. In a multi-set, we do allow something to appear multiple times, and that's also known as a bag. Why is it called a bag? Because if you go to the store and you buy fruit, so you might have 5 apples in the bag and 3 oranges and a bunch of strawberries. The strawberries might get mushy if they're in there with the apples. Okay, then we have a stack and a queue, and you know what? We're going to let's have these separate pages for them. So let's talk about that individually. Okay, so what are some of the features of the stack?
First in, first out.
Okay, so the basic thing is first in, first out. That's good. All right, and we call that FIFO. And what are some of the important operations there?
Push and pop.
So we have push, we have pop, we have, as I said before, we could have is empty. Those are the main ones. All
And
right,
I think I made a mistake. Shouldn't that be last in, first out? I think that was my mistake.
I'm sorry, you are correct. You are correct. Last in. So these are the main operations. Sometimes we have a top. Okay, which would give you the top of the stack without actually removing anything. Okay, sometimes we have is full if there's a capacity to the stack. Okay, so may be limited by, actually, we should say. Okay, and how is this typically implemented?
Array.
With an array, that's correct. Okay, good. All right, let's move on to the queue. Okay, so we have, this time it really is first in, first out. And what are some of the main operations for the queue? So we have, let's say add, sometimes called NQ. And we have remove, sometimes they call that GQ. Okay, what other things do we need? You could ask if it's is empty. You could ask if it's full. What did we say here? Let's just say one more thing here. Let's say pointer. Okay, let's go here. So what about here? What kind of pointers do we need?
Point to the current, like first element.
We need both, right? Right? Okay, how do we typically implement this?
Circular array.
So, so obviously it's not really a circular array, right? An array is an array, but you're correct. That's what we call it. Okay. Let's just say, call it wrap around using mod arithmetic. All right. Anything else you want to say about the queue before we move on to the next one? Okay, that's good enough for now. Okay, list. Go back to that again. Supports insertion and deletion at arbitrary positions. Simply or okay, so it could be singly linked, doubly linked. Anyone know what a skip list is? So what's the problem with a single, let's say a singly linked list?
In order to access an element before, you have to go through the entire list again.
Yeah, you have to go through the whole thing. All right, and doubly linked at least lets you go from either end. So what does a skip list aim to do?
Reduce the searching time.
Yeah, and how does it do that? So you're correct. How does it do that? What's the basic idea?
Skip forward by find amount.
You can jump from like one position to a position far away. Now, where you put those links, you know, whether you use a random approach, Fibonacci approach, so there are a lot of variations of that. But basically, it allows you to jump from one position to a position that's farther away. All right, anything else you want to say about lists? If array has max capacity, if list variable capacity rebuild a bigger array. And what about the uniqueness?
It could have multiple of the same elements.
Okay, so not necessarily unique. Okay, anything else you want to say about that? Before we move on to the next one. Okay, I don't think I made one for. Okay, set. Okay. So the set elements are unique. No particular order. Supports, let's see. This element. We have union, intersection. Okay. All right, then we have a map. Okay, so here we said mapping from key keys must be unique. Okay, and values not necessarily unique. Multi-map allows multiple values per key. Okay. And fast lookup time. That's one of the reasons we like this. All right, what's a heap?
Is a heap uses like minimax?
Okay. So for a min heap, delete Min, max, heap supports delete, max, both need restore heap by okay. All right, and then we have a tree. Okay, so fixed root. Okay. Arbitrary means that each, let's say, so n equals 2 is binary. No, I'll call it an emery tree. Okay, key features are, let's say, are height, okay, and then we have forest. I'm going to come back to the forest in a second, and we have a graph. All right, what are the key features of a graph?
Nodes connected by edges.
Okay, so represents relationships. Okay, so we have nodes, also known as vertices. And edges, what do we call them? Arcs. Edges. Okay, what about implementation? What are the main ways to implement? You can have an adjacency matrix. And you probably learned at least one other one.
Maps, you can map each node to the ones they're connected to.
Okay, so we can have what's called an adjacency list, or it's also known as adjacency table. Any other implementations you may have come across? There's something called the edge set, where you just have the list of the edges and the vertices are sort of implied. And you can also use a hash map. All right. So that's what we're going to say about graphs right now. And let's just come back to a forest. A set of trees. Let me put in a keyword here, disjoint. What does the word disjoint mean?
Not connected.
Non-overlapping, right? Okay. Okay, and it should support create set union and find. Okay, so union is to combine two trees into one. Find is to determine which one it is, okay? So this is going to be important when we do graph algorithms. It comes up there, comes up in other contexts as well. Right, so I think that's pretty much it for this sort of sneak preview. Just two things to look at over here. So one of them is we have this table here, whether the order is important, right? And whether elements need to be unique. There's some debate about some of these things. And also I gave you this cheat sheet here. Sorry. Sorry, this is just the Zoom from previous class. Okay, so I took this from bigocheatsheet.com. It shows you some of the primary data structures and the time associated with them. All right, so that's our brief review of data structures. We'll go into some detail on some of these in other lectures, but that was our sort of a sneak preview. So what we're going to do now is we're going to code our first assignment together. We have about an hour in which to do it. And we need a volunteer. So who wants to be a volunteer? The good news about volunteering is, number one, it means that at least your program will be working. And the other thing is I pay attention to who volunteers in class.
I'll do it.
Daniel, you'll volunteer? Okay, great. So if you want to close any tabs that have sensitive information that you don't want to share with your class, and then ask you to share your whole screen. So don't just share one window, share your whole screen, because we're going to go back and forth between the PyCharm and the assignment, and possibly looking up things in Google here and there, like Geeks for Geeks. We're going to need to grab some code from there. Okay, so whenever you're ready, if you could share your whole screen.
Oh yeah, I have to figure out.
Open up your PyCharm. You have PyCharm working, right?
Yeah.
Okay. For those who didn't see it, I did send out instructions for how to install Python, how to install PyCharm, rather elaborate instructions.
Is it visible?
So we see your browser.
Okay.
That's good. We will need a browser to grab the code.
So I just.
You're going to do new project.
Okay.
That's great. And you can say create in the bottom right corner. That's great. And we're going to rename this. So go on that tab where it says main.py. And you see, go on the tab and right click on the tab. No, the tab right there.
Oh, sorry. Oh,
right there. And go to rename file. Up. And we're going to change that to assignment1.py. Good. Refactor. Okay, you could have an underscore if you like, that's fine. Okay, so first of all, go to the assignment, open up the assignment if you don't have it open already.
That's for everyone else, right?
In the Google Drive, go to the Google Drive,
Oh.
open up the assignment, the document, the Google Doc. Go to assignments, click on that. Okay, and again, we're doing searching here today, all right? So I want you to go to, let's look at the tasks and grab that comment there. You know, the comment
Oh, this.
that, yeah, and paste that at the beginning of your assignment. You can wipe out those comments that they give you, lines 1 through, okay, fine. Okay, so Instead of Jane Doe, you're going to put your name there.
Do you want us to do this along with
Yeah,
you?
everyone should be doing this, as you gotta do it on your own, so. If you just want to put a space before your name, so it aligns with the other ones. Okay, good. All right, so we're gonna create a function called main. So go down to always leave 2 blank lines between a section, so another blank line. Another blank line, DEF for define. And then MAIN. Parentheses, because it's a function. And a no space before the parentheses. And put a colon after the parentheses. So function names in Python need a, no, after the parentheses.
Sorry.
Single colon, colon. Good, and then we're gonna write the word pass. On the next line, write the word pass. Pass is a placeholder. That means right now I don't know what's going in the main function, and I'll come back to it later. All right, I want you to go back to the assignment and copy in the 2 lines that I gave you. Go in section 4, copy those in. What that means is if you import this module into another program, then it will not automatically run the main. Okay, so we have an extra parentheses there. I think that's my bad. Get rid of that. That's good. Okay, that's great. All right, so now we're going to write a function to create some random numbers. Okay, so let's go to the assignment. And we're going to call it random list. Okay, you see that in section 5? Grab that function. Okay, copy that, and but don't put it there. So we always want to have that if name stuff on the bottom. So you're going to put your functions above the main, above the main. No, above the main.
Oh, right.
Okay, so we're going to put a def before it, DEF. All right, and in order to work with random numbers in Python, we need to import the random module. So let's say leave 2 blank lines after your comments, put import random. Good, and now in your random list function, let's create a variable. We'll call it, I don't know, rand list inside your function. There's no colon there, no colon there. Okay, go inside the function that you're working on. You need a colon there though at the after your function name, and you could call it L for list. How's that?
So the name goes after the colon.
And on the next line, okay, in the next line, you could say RND list. How's that? Or you could just say numbers. How's that? Numbers. So rand list, say numbers. Instead of rand list, instead of it, just say numbers.
Okay.
Okay, and get rid of the blank line on line 11. And we're going to make it equal to an empty list. So say numbers equals bracket, empty bracket. Square bracket, like that. Exactly, good. No, square bracket. Square bracket is for list. Okay, so we're going to make a loop. So on the next line, you're going to say for I in range parentheses, size. No, in range, the size is in the parentheses. Okay, close parentheses, colon. And then you could say numbers. And on the next line, okay. Good. You could say dot, okay, let's do this. So say RND equals, so the numbers. Well, instead of the numbers, RND equals no, we're gonna say random dot instead of the numbers. Get rid of the numbers.
Okay.
Random is the module that we imported in line 7. We're going to say dot rand int. Is there a rand int there? No. No,
Sure,
you
happy.
need the random. You need the random. Put the random back. Undo, Control Z. Okay. They give, is there a rand int function? Okay, Google rand int in Python.
There is a random function.
It is,
Rand.
okay, I don't know why it's not popping up. Yeah, that's what we want. Okay, so that's exactly what we're going to do there. Okay, so go back to the code. So you could say instead of dot random dot rand int. We want a number between min and max. So you could say min comma max plus 1. Actually, hold on, rand int is exclusive, right? Go back to that tutorial. Both included, so we can just say min comma max. Go back
So
to the
that's
code, go back to the code, just say min comma max. All right. Now, let's create another variable. I know it wasn't in the assignment, and we're gonna call that unique. Okay, so in the definition on line 10, after sorted, you could say unique. Okay, good, except you got an extra I.
Sorry.
That's okay. And now we're going to say as follows. In the next line, back to the code. Say if, except you're still inside the loop. So you need to be indented. Go back up inside the loop. So you need to indent, right? Because we're
Okay,
doing this for each number that we want. Size is the number of numbers we want. Okay, so you could say if unique and RND in numbers. Okay, so that's bad, right? So we're going to say yeah, okay, we're going to have a problem with the loop here. Let's change it to a while loop, okay? Okay, so change that to while I less than size. No, less than is the less than sign.
Oh, okay.
Okay, and get rid of everything except the colon. We need the colon still. Okay, and go to above that, you could say I equals 0. Okay, good. So now go back to line 15, and we're going to say if it's unique and R&D is in the numbers, then we're going to do continue, colon continue. Next line, continue. Next line. Put it on the next line. Good. Otherwise, you could say elif, else. You just do else, colon. Okay, and what are we going to do here? We're going to say, you could say I equals I plus 1 inside the next line.
Oh, next one.
I minus I plus equals 1. And we're going to add it to the list. You could say numbers dot append. And you could, in parentheses, you put the R&D. Okay, good. Now outside your loop. Okay, outside your loop. So you're going to unindent and indent again. Good. We're going to say if sorted, a colon. Next line, numbers dot sorted. Or is it numbers dot sort? I think. Is that how you sort it? Someone want to check that? Just go to Google. Say sort list Python. Okay, that. Okay, so you're going to call sort. Okay, so go back to the code. Numbers.sorted is a function in parentheses, good, and then return on the bottom. Return numbers. Okay, great. Okay, so let's test this. So in our main, instead of pass, we're just gonna create a call that function and make sure that it looks kosher. Okay, so you could say, my list equals. And the convention in Python is to use underscore and lowercase. Okay, in Java, maybe you have a different kind of camel case. So say my underscore list, lowercase l, and you could call our function. So you could say parentheses will make 1 be the minimum. We'll call random list. And 1 comma, let's say 1,000. And then the size we're going to have, let's say 20. And we're going to say sorted equals false. Okay, capital F. And I recommend, a good practice is you can name your parameters. So you see where the 1 is, you could say min equals 1. So go back to where the 1 is and say min equals 1. And you don't need the spaces there. Okay, and then you could say max equals 1,000 to just make it more clear what we're doing. Size equals 20. Okay, you don't have to do this. And sorted equals false. I do want it to be unique. Okay, so you're going to say unique equals true. And we're going to call that. You got a minus. Okay, beautiful. And then we're going to print my list. So if all goes well, we should have 20 numbers between 1 and 1,000 that are not sorted, but are all unique.
So just run that.
And you just run that. Okay. All right. That looks pretty good. Yeah. Okay. So let's go back to the assignment and see what else we need to do. The next part of the assignment is going to be coding a whole bunch of search functions. And for this assignment, you are allowed to use code. So the first search function is just going to be the built-in search. And I'm calling that native search. Okay, we don't know, it's a black box, right? We don't know how Python is doing it. So we're going to create a function called native search. And again, don't do this above the main after the random list. So we're going to put all our search functions together. And good, you already put the 2 blank lines, that's great. Call it native search. And we're going to have all of our searches are going to have 2 parameters, list and key. Okay, and it is a function, you need a colon and return. And I would skip the blank line there. I don't think we need the blank line in that case. Return list dot. You know what? It doesn't like list because list means something in Python. So instead of list, let's call it my list. Okay, and then you can say my list dot index. Okay, of key, parentheses key. Okay. All right. Okay, so here's what we're going to do now. You're going to call print in your main to test this. Okay, we're going to call print. And we're going to say native search. We're going to pass in my list. And we're going to pass in the 10th element of my list as the key. So we know it's going to be in position 10. So we know if we get the right answer or not. So you can say my list bracket 10. No, my list is the list. And then comma, the key is going to be my list of 10. Exactly. Okay, so we should get back the number 10 because we're passing in the 10th element. It should find it. Okay, so let's run that. Okay, that's good. That's good. Okay, so that's native search. All right, we just did another task. Let's move on to the next one.
So linear search.
Okay, good. And we're going to use my list for all of them. Okay, so we want to keep the signatures all the same. And again, we want to double blank, two blank lines between functions. Okay, now for this one, you're going to use the code from Geeks for Geeks. We might clean it up, but we're going to use the code from there. And if you could just put a comment before that function with the link that we're, so inline, put a comment before that. Good. You could say from space, put a space before the hash. Yeah, there, like that. From, and then pass in, well, no, pass in the link, the whole link.
Okay. So we're searching for linear
No,
search.
no, I gave it to you there.
Oh, right, sorry.
Okay, it's in the assignment, but that'll also work. Okay, fine. Fine, so now you're going to go down and they should have multiple versions of this. We're going to grab the Python 3.1 unless you're working in a different language. So you just grab those lines there.
All of it.
You don't even need all of that. You just need from the for loop, you already defined it. From the for loop to the return. That's all you need.
Okay.
No, you don't need all that. Just from the for loop to the return.
Okay. Sorry. Yeah.
That's all you need. That's correct. Okay, paste that in. Okay, now let's take a look here. So what is n? N, add a line of code to say what n is. So before the for loop, you need a, no, inside the function.
Well,
You say n equals len of my list. Len for length,
okay.
parentheses, my list. Good. And now instead of ARR, we don't have an ARR, you're going to put my list. You know what? Let's do it like that. So in line 26, go back, let's change my list to ARR. And change it in line 27. Okay, and change it in line 31. And you don't need to change it there. Okay, what is it complaining about? What's that underscore there? Can you see? Oh, it doesn't like the parentheses probably. Oh, the X is key. Change the X to key. And we don't need those parentheses there. Those are redundant parentheses, so we'll get rid of those. Okay, that's good. Okay, we're not even going to test it right now. I'm going to trust that it works for now. And let's move on to the next one. Once we get a bunch of these, we're gonna test it. Okay, everyone remember how linear search works. Basically, it goes element by element in order until it finds it or it arrives at the end, right? Okay, we're changing list to ARR. Good, and you're going to go to Geeks for Geeks. Put that comment in there. grab that link, that's right. And if you could just, yeah, use the same convention. So from perfect. Okay, go down, find the Python-based approach. This is the recursive one. Yeah, we'll use this one here. Okay, so if you see here, we actually need a helper function here. Okay, so if you could copy all that code into a separate function right above it. Actually, put it under the comment. Right under the comment, and we're going to create a new function called def binary search recursive. Good. And okay. We need the key, but before the key, we're also going to put the left and the right. Okay, so parameters left and right. Good. Okay, now paste in all that code. Okay, so you know what? Since they're using L and R, we're going to change the left and right to L and R to just minimize the work we need to do. You could change it in the definition. Okay, and I don't like their comments, so if you want, you could get rid of their comments. Usually over. Okay, and I don't. You can get rid of the blank lines between it. I like to keep things compact. So where Python doesn't want the blank lines, I don't want them either. Okay. What's that underline line 43 about? Okay, yeah. So here's what we're going to do. In line 50, after line 55, you're going to return right there. You're going to say return binary search recursive. Yeah, just click it. ARR 0, comma len of ARR minus 1. No, it's the len of the array minus 1. You can't subtract one from an array.
So what do I do again?
So you're taking the len of the array and then you're subtracting 1. You can't subtract 1 from the array.
Right.
Comma key. Good, and get rid of all that other code that's beneath it. Good. Okay, and now let's go back to the other one and fix that. Okay, so line 43 looks good, 44 looks good. Here's what you're going to need to do in line 42. You're going to put an int around that. So you say mid equals int parentheses L plus R minus L divided by 2. Single divided. And actually put the int not around, I know I told you to do that, but get rid of the int where it is and put the int around the other part. That right there. Yeah. That's right. Okay. All right. So in line 43, we need to change that X to key. And in line 43, we need to do the same thing. In line 46, we need to change binary search to binary search recursive.
X stays here too. Or
Yeah, you need to fix those, correct?
This binary search
Binary
is the red
search recursive, right?
Okay.
Okay, good. Okay, so another one down.
Maybe not a comment that also.
Okay, we're gonna get the Python 3 version. And we're also gonna need a randomized binary search recursive here, a helper function. Okay, like we did in the other one.
Okay. So this one would be recursive.
Okay, so we're gonna say change list to ARR. Okay, we're gonna put an L and an R for left and right before the key. Good. And we're gonna paste that code in.
This one.
Yep. Let's clean up the comments there. Okay, instead of get random, well, you can clean it up first, okay, if you like. Okay, so you're gonna need to change the X's to key. Okay, let me explain to you what we talked about binary search yesterday. What we didn't talk about is randomized binary search. Is anyone familiar with it? So remember how binary search works. Binary search works by taking a midpoint, right? And saying, let's look at the midpoint, and then we either do recursion on the left or on the right, depending on which side it's on, right? Randomized binary search says, don't pick a midpoint. Pick a arbitrary point in between the two places. All right, so it's going to use a random. So in line 60, we're going to say random dot. We're going to use the same syntax we had before. Random dot rand int LR. Okay, good. And I saw you were fixing the other problem. Good. Okay, is all the red lines gone? Why is
We're gonna have to make the. Yes. Okay, environment. Okay, so where do I get the equal for?
Same strategy as before. Okay, so we're going to return randomized
Oh.
binary search, recursive, ARR 0, comma, len of ARR -1.
In the recursive, the random recursive, we have to say the returns for, you have to change that to recursive function.
I'm sorry.
In line 64 and 65, you have to change the functions.
Oh, you're correct. Yes, thank you.
Thanks.
Good. And we need to pass the key in line 70. Okay, let's just test this, okay? So here's what I want you to do. Go back down to the main. And let's create a variable after line 76. After line 76. Call it key equals mylist10. Okay, and then instead of, no, bracket, it's a list. So we need brackets. Good. And now in line 78, replace mylist10. No, in 78, replace mylist10 with key.
Also, for the binary searches, shouldn't we make the sorted true? Otherwise, they won't work.
Oh, yeah. So we want them, we're going to make them all sorted to be fair. Okay. So yes, that's correct. Thank you for pointing that out. So in line 75, we're going to change sorted equals to true. Good. Okay, and well, for now, we're just gonna leave the size at 20. We're gonna change that later. Now, you're on line 78. I want you to press Control D 3 times. Okay, good. Change the second line to, I mean, line 79 to linear search. And change the next line to binary search. And change the next line to binary search randomized, or randomized, I'm sorry, randomized binary search. Okay, and if all goes well, then we should see the number 10 for each of them.
You need parentheses over there.
Yeah, you need an extra parentheses in each of those
Ah,
lines. Okay, we're going to streamline this in a little bit, but I'm just doing some basic testing here. All right, beautiful. Let's run that. And worked. Okay, let's keep at it. All right, so we got 3 more, I think, that I want to do, and then we're going to do the graphing stuff and timing. So just a heads up that there is a bug in the interpolation search. It's designed for Python 2. It doesn't work right in Python 3, so we're going to have to fix that. Right, but you know, this time I know that there's a problem there, so we'll be able to, we'll get stuck on it. And we're also going to need the interpolation search recursive.
So this is the recursive one.
So remember how interpolation search works. It uses a guesstimating approach to figure out where it expects it to be. By the way, line 77 really belongs with line 76. So you can combine those onto the same line there. Just Geeks for Geeks has a very small window, so they move things over to the next line a lot. Wait, no, that doesn't look right. That looks right. Okay. All right, so in interpolation search recursive, we're going to need to pass in, let's do L and R just to be consistent. Okay. You lost your key and you lost your ARR. Okay, so let's change our lows to L and our highs to R. And our X's to key.
I'd do like a search and replace. Would that be faster?
You could, but I don't want to change any other code here, so it's only a few lines. It will not really take very long. Wait. I think did you change something wrong there? That should be a high, right? It should be the R. You can move that onto one line. Good. And you're going to change that to interpolation search recursive. Okay. Interpolation search recursive. Okay, so there's actually there's a bug. Okay, the bug is in line 76. Okay, and here's what we're going to do. You're going to put an int after the POS equals in line 76. After the equals, POS equals. Okay, int doesn't need a space though. It's a function, no space. Okay, so we have the L is good plus double parentheses R minus L is good, single slash, good. ARR of R is good minus ARR of L is good, times key minus ARR of L. I think that's good now. What is it complaining about in that line?
It was saying, I think that's.
No, you don't need
Sure.
parentheses. You don't need parentheses. Why is it still underlined there? Oh, I know what it wants you to do. It wants you to say if L is less than or equal to R and key. So say and ARR of L goes on the left. So after the and, right, you can do, it's like a between. So after the and,
Mhm.
put your cursor after the first and. Right there, you're going to say ARR of R. I'm sorry, ARR of L. ARR of L. Less than or equal to key. And then after the key, say less than or equal to ARR of R. Get rid of that other and there and the thing after. Yeah, so it wants you to simplify that. That's good. Okay, now we need an interpolation search without the recursive. How are we doing on time? 25 minutes left. Okay, we're in good shape.
We do
ARR,
same configuration. as
Key.
others.
key. And then return.
Oh, I'm in the return line. Should I?
Like the other one. No, key, parentheses, colon. Next line, return. Oh, okay. I'm sorry.
Yeah,
I'm
this is
sorry.
it, yeah.
Okay, so you need the like what you did before. So you need to say 0, comma, len, ARR. Yeah, exactly. Okay, wonderful. All right, let's do the jump search. Okay, remember what a jump search is, right? It jumps around. Unlike the linear search, which jumps in units of 1, the jump search tries to be a little bit smarter about it.
Recursive.
I think maybe not. It might be a loop. They might use a loop.
Okay. So,
Yeah, they're not using recursion in this case. So you just copy all that. Good. Okay, you got an extra space in line 91. At the beginning of line 91.
I see that.
Okay, change list to ARR. Change your, we need to import math. Okay, math is a package that does math stuff. Put that on the top of the page. Good. Go back to the code. Okay. And let's see, change your X's to keys. Okay, you can get rid of those comments if you want.
Yeah.
Okay. Okay, what is it? Why is it complaining about the returns? Can you hover over one of those? Oh,
The
let's-
ends, the variable n, I think because of
Oh, we
that.
don't have an n. Yeah, so on the top, say n equals len of ARR. Got an indentation problem there. Actually, everything is indented off
Yeah.
because when it was originally, all those other things need to be, it should always be indentation of 4. Okay, wait, what are you indenting? You're generally doing 4, so they should all be 4
I don't know. I think when I pasted it, it was.
because you were indented off at the beginning, so you need to fix that. Just, okay. Yeah, you're gonna make yourself, okay, there we go. Okay, we still don't, it still doesn't like the return. What's the problem with the return? Hover over the return. Your indentation is off. So,
That's
yeah,
the-
because your while loop, look at your while loop, got
Yeah.
messed. Need to indent in units of 4.
If you do Control Alt I on the highlight section, it'll just indent.
Yeah, yeah, you can do that.
Is it Control I?
Control Alt I.
Yeah, for the, it's basically indentation, I for indentation. Okay, did that clean it up? Or the underscores gone?
No, I have a Mac, so I don't know. Is that the same?
Maybe it's Command Alt I. Not sure on a Mac.
Okay, the underscores are gone though, aren't they? Okay, but the return
Yeah.
-1 needs to be indented. Line 100 needs to be indented. Okay, and line 104. Okay, I think that's good now. Now you got way too much indentation on line 106.
Good. Yeah, I think so.
Okay, all right, let's go to the bottom and let's add 2 more lines. So go to line 117, press Control D. Twice. Change 1 to interpolation search.
Okay, and this one is the.
Jump search. Okay, run that, make sure we get 10. Ooh. Okay. So which one's off the jump search? All right, let's try to understand that. So we need to,
I think previous needs to be cast in integer
yeah, how?
because they cast it when they're using the array.
Okay. All right, I guess we need to do that in line 106, right? Is that the only prev that we have? So line 106. Yeah, you need to put an int around that. Okay. That's better. All right, so I think we just have one more, right? One more search, and then we have to do the timing and the graphing. So the next one is Fibonacci search. Okay, so who knows what Fibonacci numbers are? Familiar with those? 0, 1, 1, 2, 3, 5, 8. What's the pattern in Fibonacci? We'll talk more about that later in the course. What's the pattern?
You add the previous two numbers together.
Right, so each number is equal to the sum of the previous. And what does it have to do with searching? The answer is that Fibonacci numbers arise in a lot of places, and the pattern that is used is a Fibonacci pattern. Okay,
We would need a recursive one, or
I don't, it doesn't look recursive, right?
no? Okay.
Okay, you put the link in? Yeah, you put the link in, great. Okay, so let's do our usual changes.
The,
Okay, so first of all, we're going to need to set n equals to put array in line 112. Good, and n equals the len of ARR at the beginning. Okay, line 117, it doesn't like the parentheses. You can get rid of those. So you want to always be looking at all those tilde, I mean, all the underlines.
yeah.
You can also look in the bottom upper right-hand corner. You see where it says 320. Those are errors. Okay, so we want those numbers to go down to 0.
Where did you say you see that?
Look in the upper right-hand corner of your browser. Not your browser, of this ID, right? Move your mouse a
I
little
see,
bit.
yeah.
You see that 3 and the 26? So those are
Yeah.
errors and warnings. So you
Okay.
really want those numbers to go down. All right, so we'll start with changing the X's to key. Now, that's what you're working on now, great. Line 135, you can get rid of the parentheses. Okay, look at that, we got rid of the errors now. Click on the 15, let's see what that's about. Oh, okay, if you want, you could do that. We could fix those. Okay, so you could say fib underscore. Let's do fib underscore.
You mean like that, or
You could say fib 2, it works for me.
yeah?
The other one's fib 1. And you could do the fib and you could just do b fib. To change in line 116, change the fib and to fib. You got something in line 135 still?
Yeah.
No, that was yeah, right. Okay, you could also change the n-1 to get rid of the parentheses in the n-1. Generally in a brackets, you wouldn't put spaces. Okay. All right, how are we doing there? Click on that 14 in the upper right corner. Let's fix that up. Okay, so if you go on the bottom, okay, click on the shadows built-in name Max. Click on that. Okay, so we'll say change that to min num and max num. And max num, because those are functions that are built in, and change it in line 15. And put a space after the comma.
If you hover over them, it has like a rename thing. where it's-
Yeah, it'll help you do it automatically. Okay. And it doesn't like the sorted, so you could say do sort. Instead of sorted, do sort. Okay, and change it in line 21. Okay, go down to the bottom of the code. All the way to the bottom. And change it there, all those line 140.
What do we name it again?
Min num.
Right.
Max num. Okay, and do sort equals true. Okay. All right, let's go to, what else is it complaining about? Click on that 10 again. All right, let's fix the too many blank lines. That's an easy one. Okay, get rid of a space, line 109. No, line 109. Good. Okay, ambiguous variable name we're going to leave alone. Too many blank lines. Let's click on that. Get rid of a blank line there. Should always have two. Another one. Too many blank lines. Blank line identifier. Get rid of some of those till the error message goes away. Okay, it doesn't like CSCI. That's okay. What's that last one there? The MTH. What's that? You can get rid of those comments. We don't need those 3 comments there. Okay, all right. That's good. Okay, we haven't run it with this yet. Let's go to line 148, Control D. And change that to Fibonacci.
None?
Okay, that's good. All right, we're ready to run some trials here. Okay, so watch this. Okay, let's create a variable called searches. Okay, so after all those print statements, you can comment out the print statements. Actually, comment all of that out. Okay, so just select all that stuff there. No.
Is there a way?
I think if you do control
And the
control slash will do it.
Start.
Okay, the stuff before it also. Okay, good. So let's create a variable called searches. Okay, and you know what? Okay, we'll call it a bracket. You know what? Change the name of native search. Go back up. Go back up to native search and change that to Python search. Okay, good. Go back to that variable. And we're gonna see searches equals. Okay, searches equals bracket. We're gonna make a list of the searches. So this is cool. We're gonna iterate over our functions. No, so in those brackets, put it in the brackets. You're gonna say Python search, comma, linear search. No, we're not calling the function. It's just the name of the function. So without the parentheses. Linear search, binary search recursive. Binary search recursive. Interpolation search. I'm sorry, not binary search recursive, my bad. Randomized binary search. Binary search recursive is part of the binary search. Okay, interpolation search is good. Jump search. And Fibonacci search. If it's going too far to the right, you could always put a return line in between. Okay, good. And now we're going to make a variable called dict searches. It's going to keep track of stuff for us. DICT for dictionary, underscore searches equals curly braces. Open and close curly braces, like that. Good. Now we're going to make a loop. Okay, say for search and searches. Okay, good, colon. Dict searches, bracket, search dot underscore name. You see that second thing? You could click that there, that name. Good. After the bracket, say size in bracket. Sorry, the size is also in bracket. So this is going to be okay. Equals 0. So this is, we're initializing this dictionary. Okay. Now we need to make a loop. Okay. So before that, somewhere before that loop, let's say before the searches, for the list of searches, you could say sizes equals, and for now, we're going to just hard code them. We could do some list comprehension to make it better. Oh, you could do that. So you could say equals bracket 1000 times I for I. No, inside the brackets still. This go list comprehension for I in range 10. Let's do range 1, 10, 1, 11, actually, 1, 11. Inside parentheses, 1, 11. So that's going to go from 1 to 10. Okay, good. Good. Okay. So now we're going to say for, you see where the first search and searches is? Before that, right before that, we're going to make another loop. No, down.
Yeah.
Right before that. The line before that, make a good for size and sizes. Good, colon, and then indent the for search and searches. And get rid of the 155. And indent the dict searches stuff. Okay, and now you're going to say after that line, go down one, indent, unindent one, no, there. Okay, say for trial in range, and we're going to do 1, trials plus 1. Let's do trials plus 1. That's right, colon. Okay, and then we're going to do ARR equals. So now we're setting up the random data for the trials, and we're going to use the same random data for all of them. So ARR equals random list. Call your function random list. That function.
Oh,
That function there. And we're going to pass in the min num is going to be 1. Okay, the max num is going to be a million. Okay, the size is going to be size, right? That's from our loop. The do sort is going to be true. Capital T, capital T. And the unique needs to be true. Otherwise, the sorts may not return the same thing. Okay.
this one is
Good.
getting better.
Okay. Okay, next line. Oh, if you want, you could say trials equals 100. So put that before the loops. Okay. Good. And now we're going to see IDX for index equals. Okay, random.randint. Randint 1 comma size -1. -1 is after the parentheses. Okay, good. Okay, and then you could say key equals. So we're picking the thing that we're going to look for. Okay, so key equals ARR bracket IDX. Oh, sorry. We should let you go. Okay, so we're gonna pick this up at the beginning of next class. Okay. Okay. Let's just.
Should we save this somewhere? Is this shared with everyone or?
You know, let's just do a few more lines. We're not going to do the graphing. Let's just do a few more lines here so we get it. Okay. So we'll say as follows, for search in searches, start time. If you go to the very top, we're going to need to do one more import here. The very top of the program. And do import time. Okay, good. Now let's come here for search and searches. Start time. Start underscore time. Start underscore time equals time dot time. So that's going to be the start time, right? Good. Next line is IDX2. IDX2 equals search. Yeah, so we're calling the search. The search is a variable for the search we're up to. ARR comma key. Good. And then we're going to get the end time. So end time equals time dot time. Okay, next line is net time. It's how much time elapsed, right? Net time equals end time minus start time. And dict searches.
Wait, and net time equals what?
End time minus start time. Okay, and then we're going to say dict searches. Click it, yeah. Bracket. Yeah, bracket search. Dot. That name, that thing there, that first one there. Good. Name, comma, search. I'm sorry, bracket. Good, and then another open bracket size. plus equals after the size. No, not in there. Not in there.
Oh, sorry.
Plus equals 1,000 because we're going to convert from seconds to milliseconds, 1,000 times net time. Okay. And if you want, after that loop, after all that loop, you could just print dict searches. Okay, we'll make it fancier next time. After all that, so undent, print dict searches. Okay,
Index.
let's run that, and then we're not going to be able to do the plotting today. We'll pick that up next time. Why doesn't know what Python search is? Oh, we need another thing here. Okay, so after the dict searches equals curly braces, say for search and searches. Good, colon, dict searches, bracket, search, dot, underscore, underscore name, that, then close bracket, you already have that, equals, no, get rid of that, equals, curly braces. So we're just initializing that. Okay, run that. It might be slow. You might want to change the, kill it, change trials to 10. Okay, in line 152. Finished? Okay, so you see what we have there? We have the names of the searches, we have the sizes that it ran, and how much time it took. Now, it's hard to read it. Next time, we're gonna get ourselves a better, better table. Okay, but basically, we did good here.
I got division by 0 error.
We got a division by 0. Are we dividing anything? Oh. Is that coming from like interpolation search or one of those?
Yeah. Interpolation search.
All right, so I think you might need to put some kind of print statement in to figure out what. I guess something is coming out to be 0, so you got to track down where that's coming from.
We only just divided one separate on the entire thing. So
Probably only, there should be a stack trace, right? Where you can click on something and it'll take you to the line.
I don't know what line it is for.
I'm saying, are you getting a stack trace?
Yeah, I'm gonna stack trace.
So it should take you to the line where the problem is, and then we can diagnose. Okay, so we're gonna stop here. You can try to play with that if you want, but next time we're gonna get a nice tabular form for the data and also do some plotting. Okay, and then we'll have a working program, so then you can do this same thing for sorting in a different assignment. Okay. All right, so thank you very much. Thank you, Daniel, for being our coder today.
Thank you.
Okay, take care, everybody. Did everyone do the attendance? What was the attendance code again?
3032.
3032. Okay, great.
Professor, should I share this with the class or something?
If you want, you could put it on Slack.
So just as a file, right?
You can post it. By the way, so if you go into Slack, there's a special module for code, right? So if you look on the things you can click, one of the buttons has a, like it looks like a bracket, and that's for pasting code. So you don't, or you can attach the code. So it's better not to just do copy and paste. You either want to attach it, or you can use the bracket in the Slack. Notice you'll see a bunch of things there. So one of them is for like creating a block of code. Okay. All right, everyone, take care.
Thank you, Professor.
Bye-bye.
Thank you. Have a good